Hi there. If you read before just clicking on this video, some of you are good at the reading part, some of you just get to the video, um, or you noticed in my video yesterday that page 16 does not look right in your math binder. Page 16 is an accidental repeat of page 15, which is not what it's supposed to be. Page 16 is supposed to look like this. So if you are in class, you came and picked one of these up from me. If you are at home, I uploaded the PDF so you can print it. Or if you're at home and you're like, I don't have a way to print it, Miss McGowan, that's okay too. You can just get yourself one of your handy lined papers, and you can just format everything that's on here. Just do your best to write it all on here. You can draw the boxes if you want or whatever. But I am going to show you right now what we're going to do to format it so that it goes in our binder correctly. So if you got the paper from me, you'll notice it's already 3-hole punched, and some students tell me like, you 3-hole punched it on the wrong side, Miss McGowan. Sometimes I do that. We all make mistakes. But this time I actually did it that way on purpose. So you should have the page number 16 down here in the left-hand corner with your 3-hole punch on the right-hand side when you're looking at this right side up. Which means if you're formatting it on your own paper, you want to make sure that you've got the 3-hole punches on the right-hand side. I'll zoom out a little so maybe you can see better. Make sure you've got the 3-hole punches on the right-hand side and that you label the page number 16 down in that left corner, okay? So 3-hole punches over here, 16 down in this corner. If you picked up a paper from me, it's formatted that way already. 3-hole punches over here. If you printed it at home, you'll have to 3-hole punch it yourself, which could just include popping it right onto your binder pages. That does work. Okay, and I'll show you why it's formatted that way. When we're done with these notes, I'll show you how it's gonna go back in your binder and hopefully feel like it was there all along. All right, so yesterday, after you guys took your assessment, you did the what do you know about area and volume? And you might have looked at my key 1 through 4. I would imagine you looked at that key and were like, yeah, that's pretty much what I did. I squared stuff, I squared stuff, I cubed stuff, that's fine. For the second half, 5 through 8, there was probably something on there that you'd never seen before. And you saw me write the words and hopefully you wrote them down. We're going to clarify today what those words are and what that is all about, okay? So I'm gonna grab some pens here, so I'm ready to go. First of all, let's give ourselves a little bit of information on the top here. These notes are called squares and cubes. Those have many meanings mathematically. Oftentimes when we think of squares, we think of the visual square. We've drawn some in class, and it fits together, absolutely, that's what a square is. But also mathematically, to square something, we write it like that as an exponent, and what it means is multiply something by itself, right? Which is why it goes along with a shaped square, because that's what you do to find the area, is multiply the side length by itself. So we are going to go across this row and we are going to square these things, multiply them by themselves. If x is 1, x squared is also 1. Why? Because 1 times 1 is 1. Now this first row of numbers should already be familiar to you. They are called perfect squares. We worked with them a ton in the number system strand. And there's still going to be a big deal here in the EE strand, equations and expressions. So if this is my x value, this here in red is x squared multiplied by itself. All right. Now here in blue, this row tells me to cube it. Now again, when you hear the word cubes, you might have a visual that comes in your mind. That is a perfectly valid mathematical visual, a cube. A box where all the side lengths are the same length, all the edges are the same. So now they want me to take all of these x values and instead of squaring them, they want me to cube them, which means multiply it by itself, but we do it 3 times, right? Now the first number that you write down counts. So 1 cubed is just 1 times 1 times 1. a total of 3 times. Sometimes you guys do this weird thing where you add in an extra one, but it's a total of 3 times. And I think that maybe you add in that extra one because you're like thinking it has to be 3 multiplication signs. It's just a total of 3 of whatever you're multiplying. So 1 times 1 times 1 is 1. Okay. 2 times 2 times 2 is 8. 2 cubed is 8. Say that sentence to yourself a couple times. 2 cubed is 8. Okay. And also you can of course type this in your calculator. We worked on this a little last week when we were evaluating, but remember we have this button here that's underneath pi, 2 to the third. That's how we type that in. Okay. 3 to the third. 3 cubed is 27. We can keep going in our table here. 3 cubed is 27. 4 to the third is 64. You can keep typing them in to verify. 5 to the third is 125. These are perfect cubes. Look, 6 to the third, 216. 7 to the third, 343. 8 to the third, you guys can keep typing them in. 512. 9 to the third, 729. And 10 to the third, of course, is going to have 3 zeros on it, 1,000. So these numbers in red are what we get when we square things, and these numbers in blue are what we get when we cube things, multiply it by itself again. All right, now this is where we have to take our thinking to a little bit more of an algebraic place, where we say, okay, if I have a little equation here. So question number 1 says, how many numbers will make this equation true? Well, let's put that together with up here, okay? If I tell you that x squared equals 16, what was the original x? Well, a lot of people right away tell me, oh, yeah, x has to equal 4. And you're not wrong. But I'm actually going to tell you that x could also equal something else. What else could x possibly equal? You're thinking backwards. What multiplied by itself gives me 16? 4, Miss McGowan, we already told you that. Guess what? So does this one. If you don't believe me, watch. Here's what I'm saying to you. I'm saying to you that yes, 4 squared is 16, but so is -4 squared. Remember that little conversation we had in class the other day about parentheses in your calculator and how important they are to tell your calculator that the base is negative? Why does that happen? Because of what you learned in 7th grade, that same signs, positive product. A negative times a negative is a positive. So how many numbers will make this equation true? For this equation, actually 2. 2 answers will make that equation true. And what that means is that equation has 2 solutions, because in mathematics, what does a solution mean? Well, it's a thing that makes that true. This equation has 2 solutions to it, because we don't know if it was 4 that got squared or -4 that got squared, because both of those give us an answer of 16. All right, now look at this one. How many numbers will make this equation true? And then people want to say 2, that one has 2 as well, right? No, let's find out. Well, x cubed is down here. I'm going to use blue since I'm cubing stuff now. Down here I see 64 right there in my table. Now that did come from cubing 4. So we know that 4 cubed is 64. Here's my question. Is -4 cubed also equal to 64? I'm going to type it in, and I'm going to make sure I put parentheses around it so that I'm telling my calculator it's a negative base. I want my calculator to know it's a negative base, not timesing by -1. So -4 to the third. You ready? You ready? Oh no, that's a different answer. So here's the crazy thing. This equation actually only has 1 solution. There is only one number that will make that equation true. Only 4. Because if I try to plug in a -4, that whole rule from 7th grade about same signs doesn't apply here because I didn't do -4 times -4. I did -4 times -4 times a -4 again, which turns it back to a negative. So here's what we need to know. Ready? Let's fill in the blanks here. When you square root a number, and we're going to clarify all of this language as we move forward. When you square root a number, you actually end up with 2 solutions. You have 2 answers because you don't know if it started as a negative or a positive because those both square to the same thing. And I'll clarify that as we go. If you're like, what did she just say? Just hold that thought and we'll clarify. When you square root a number, you end up with 2 solutions. When you, here's this new language from yesterday, cube root. When you cube root, that's a thing. That's just going backwards from cubing. When you cube root a number, you only end up with 1 solution because you're not dealing with the whole a negative times a negative equals a positive because you have that extra 1 in there. So here's how this applies to actually mathematically doing this stuff. And I'm also going to show you how to do this on your calculator. Okay, so when you do square root, I'm going to go through and find all the square root ones first. This is a square root of 64. That means I'm going backwards. Can't see where my finger is. I'm going backwards from these red numbers, but also we've dealt with these a lot, but also you could type it in a calculator if you really needed to. Square root of 64 is second square root. We've done square roots a lot in our calculator. This shouldn't be new. Square root of 64. Now your calculator is going to say 8, but what we just discovered is this could be 8, or notice I'm putting a comma because there's another option, or it could also be -8. I don't know which one it started as because this is the opposite of squaring. And if I do 8 squared, I get 64. And if I do -8 squared, I also get 64. See, I'll show you. Okay, so we have to write both of those. Now, also, I see on this one that this is the exact same problem, and I just want to change it because I didn't think I meant to do that. Let's make it, I don't know, square root of 144 instead. You can type it in your calculator. Go ahead. Square root of 144. What does your calculator say? It says 12, but actually we now know that it could also be -12. Now, if I go back to these two, 4 and 6, you notice the radical on there, right? But I sure hope you also notice that cute little 3 hanging up there. That means I'm not supposed to square root these. This is a cube root. In fact, I'm going to write this right up here. When they say cube root, you see a radical symbol with a little 3. And that is telling you to cube root it. Okay? Now that means instead of going backwards from these red numbers up here, if we're cube rooting, we are going backwards from these blue numbers. So if they say cube root of 8, here's my 8. That started as a 2, which makes sense because 2 cubed is 8. Cube root of 8 is 2. They work back and forth, just like 5 squared is 25, squared of 25 is 5. They're inverses of each other. They go backwards. So what is the cube root of 8? 2. Now, do I put the comma -2? No, don't do that because square roots have 2 answers. Cube roots only have 1. Okay, cube root of 8 is 2. Cube root of 1,331. That's not on my list. Okay, let me show you how to do this in your calculator. Ready? I can't do the square root button. That'll be the wrong operation. Do you see above that with this exponent, do you see that little blue thing right there? If I just do second exponent, there's a little, it brings up a and s with a little x there. Do you know that means you can do 4th root, 5th root, 6th root, you can do all kinds. I have to tell my calculator that this is a cube root. So ready? You ready? You ready? Here's what I'm doing. Type a 3 first, then second that button. Pause and rewind if you missed that, if you need to see it again. And then I type 1, 3, 3, 1. Now my calculator is going to figure out the cube root for me. Oh, 11. 11. And do I write comma negative 11? I sure do not, because cube roots only have one answer. Okay, by the way, and just to verify the other way, that is because 11 to the third is 1,331, just going backwards. Just like you can square and square root, you can also cube and cube root. Okay, so let's keep going. Here's another cube root. I'll give you a second to type it in your calculator. Remember to do the 3 first if you're using a calculator like this. If you're using Desmos, it's right in there. I can show you that in a second. 343. 7. Look, it's also right here in my table. 343 goes backwards to 7. Only one answer for your cube roots. Okay, here is a square root. Actually, what you guys are going to do is just practice typing these in your calculator, see what you get. If you start getting decimals, take another look. Pause me right now and see if you can evaluate the rest of these. Hey, check out those fractions at the bottom. First of all, take a look here. Did you remember that square roots have 2 answers? Cube roots have 1. Square roots have 2 answers. Now look at this. I know some of you grabbed your calculator, typed it in, and put a decimal here. You don't really need to do that. What you need to do is know that if I'm square rooting a fraction, you can square root the top and then square root the bottom. Do you see how those are just perfect squares? Square root of 4 is 2. Square root of 9 is 3. Simple as that. Square at the top, square at the bottom, you got your fraction, and then remember that square roots have how many solutions? Oh yeah, 2. So this is 2/3 and negative 2/3. Cube root of 1, cube root of 27. Took me right to 1/3. No repeating decimals, just right to the fraction. Now this one, square root of 81 is 9, square root of 225 is 15, and then I simplified it, and then I wrote my 2 solutions. Cube root the top, cube root the bottom. Fractions. You can cube root and square root separately, okay? Now, let me just add a note over here on the side. As we get into some equations here, I'm gonna twist my paper sideways, and I'm gonna tell myself that squaring is just the opposite. Oh, I messed my colors up. I can't do that. That has to be cubing. Everything cubing has been blue, so it has to stay blue. X cubed is the inverse. That's not an equal sign. I'm saying they work back and forth. Is the inverse of cube rooting. Those are opposites of each other. They undo each other, okay? Inverse. Likewise, and this is one we already knew, squaring is the inverse of square rooting. And this is where some people ask me, hey, how come we don't put a little 2 right there? You technically can, but we just always assume that there's a 2 there if we don't see anything, because that's the smallest it could possibly be. So there's no such thing as a 1 root. I mean, there is, but it doesn't do anything. Okay, so these are inverses of each other. So we're going to use that idea to help us solve these. Okay, I'm going to start you off with a couple, and then you're going to pause me again and try the rest of them. So right here, and I'm going to rewrite this so you can see what I'm doing a little bit better. This original equation says, if x squared equals 144, the question to you is, what is x? Right? That's the question. If x squared is 144, what's x? And I know you can think backwards, but I want you to just show this step with me here on this one and show me what's going on here. Because really what we're trying to do, like we did in 7th grade where we say, where's the x? What are they doing to the x? How do I undo it? What we're trying to do is get rid of the squared on the x. And how do you undo x squared? Use square root. Use the inverse operation. That's not a word, operation. So I'm going to square root this side. And remember, whatever you do to one side of the equation, you absolutely must do to the other side. So truly what I'm doing here is square rooting both sides. Okay, now on this side, I get the x out, which is what I wanted. That's what I'm trying to do. The x squared and the squared cancel each other because they're inverse operations. And what's the square root of 144? 12 or negative 12. These equations have 2 solutions. Why? Because of the square root. 2 solutions. And that's that. Let's do a couple more. You ready? I'm going to rewrite this so you guys can clearly see what I'm doing. This equation says x squared equals 256. And I'm going to rewrite this one while I'm at it. X cubed equals 27. Okay. For this inverse operation, again, I square root. Whatever I do to one side, I must do to the other side. I can type it in my calculator if I need to. Go ahead, type in square root of 256. And it will tell you 16. And then you have to remember that there's another answer, negative 16. Two solutions. Why? Because of square root. Ooh, look, this one has x cubed. Do I square root both sides here? No, that's not the inverse operation we want. We need to cube root both sides. Cube root both sides. Cube rooting is the inverse of cubing. That's how we get the x here. And then type in your calculator if you need to, or look at the table up there. The cube root of 27 is 3. Do I write comma negative 3? No, because cube roots only have one answer. All right, one more before you pause me. One more, x cubed equals 125. What's the inverse of cubing? Cube rooting. Cube rooting. And x equals cube root of 125. Make sure you're typing the right thing in your calculator, looking at the right place in the table. X equals 5. And of course, cube roots only have one solution. Okay, see if you can finish this paper. Pause me right now, give this a try, and then come back and see how you did and fix anything if you need to. So pause me, I'll wait. Check it out, see how you did. Did you remember to simplify everything? Did you remember that square roots have 2 solutions and cube roots only have 1? And let's check out this last problem, 24. Set up an equation and solve. So this one was different. I had to actually write the equation myself. Daisy is making a memory box in the shape of a cube. The total volume. This was like your problems you tried yesterday. If the volume is 216 cubic inches, if they're talking to me about volume, I need an x cubed equation. If they were talking about area, I would square it. So here's my equation. I need to cube root both sides. Type in your calculator the cube root, so 3, or look up at the chart up there. Cube root of 216 is 6. So x equals 6, but look how they asked this question. What are the measurements of the length, width, and height? Well, if this is a cube, they're all 6. All right, you're going to practice some of this on your quiz today, and then you're going to work more next week on cubes and squares and x squared and x cubed equations and a few more applications. And you'll assess on this standard next week. So please let me know if you have any questions or need any help with anything. I almost forgot to show you why it was 3-hole punch the way it is and how we're going to put it back in our binder. So here is page 15 that we filled out. Here is the pretend page 16 that is actually just 15 again. We don't need to fill that out again. What we need to do is we need to take our correct page 16 that we just finished filling out. We need to clip this in here, this direction. And the reason I 3-hole punched it that way, and by the way, if you used your own paper, you're gonna do the same thing with your own lined paper. Clip it in here, and then I'm gonna close this, and then I'm gonna take these pages, and I am actually, so I've got 15 here, you see what I'm doing, and I've got 16 here, and I'm actually gonna take a piece of tape. You can use a couple if you want. Just gonna take a little piece of tape, and I am going to, some people like to do this outside of the binder, but the 3-hole punches are a little different. So I'm gonna keep it in there. And I am just going to put a little piece of tape. You could totally use a glue stick or whatever you have, but I'm just gonna tape along the edge here. And all I want, and you can do more tape if this doesn't feel like enough to you, but all I want is I want this to turn together as one page, so I don't even have to see that in between whoopsie page. Okay, so now what I really have is I have page 15 that flips right over to page 16, the real page 16, which is what I really wanted. So that's why it was 3-hole punch that way. And again, if you have your own lined paper, do the same with that. Just put your lined paper in there, tape it to the other page, and your binder is good to go.